Okay everyone, back with part 2 of this rocket stove, rocket mass heater test and whatever. Basically here's what we got going on. I detached my barrel stove and moved it back a little bit, and my partner on this / customer, they brought me some of this flex chimney tubing, whatever, it's aluminum, and they brought me this elbow, the cap, and this reducer, because that's technically what it is. It goes from 8 inch to 6 inch, or excuse me, it's not a reducer, it's an expander, so it goes from 6 inch to 8 inch. The reason why I say that it's not a reducer is because whenever you're running the exhaust, all of your fittings should fit inside of the other one on the way out. Not, this shouldn't fit over the top of this one or you'll get leaks out. So anyway, some of this stuff is backwards, and it's different style of tubing or exhaust. You have this style that you'll see this crimped edge on, which is a little bit smaller than this style here, which is a thicker tube. You don't have that. Let me see here. Here's the small end of that. See how there's no crimping going on? It's just that ridge. This stuff is bigger, just slightly bigger, and it's a little bit thicker than this stuff here. So you got to make sure that it all matches, or you're going to be doing some cutting and bending and smashing pieces together like I have to do. So, but anyways, this is what, eventually I'm going to cut the top of this thing, not the top, but from the bottom weld of that air compressor tank, to make that whole thing like a cover, and it'll slide over the top of this. And I'll probably cut that either tonight or tomorrow, but I'm not going to worry about it just yet. I'm going to do a test run first. The idea was to create like some sort of a cover, because it's going to go over this anyways, but to create like a funnel where this thing's really down low, you know, the compressor tank, and that won't have any choice but to shove the smoke up the exhaust. I decided not to do that, and I want to do a quick burn test on it, and that's what I'm going to show you guys. I use this T instead of just using the flex, because this T gives me a flat spot up here to check temperature. And that's kind of an important part of this, is that you need the top temperature to be pretty hot. So I decided to go with that route just so I can continue testing temperatures and whatnot. And this 8 inch is big enough to cover up the riser tube, so I think that'll work. I'm going to put you guys on the tripod. I'm going to get this started. It's not running right now. I'm going to get it running for you guys. Yes, I know my chassis saver and monster liner banners are really close to this, and hopefully it don't get hot enough to burn those. I'm not going to worry about it. I think we're okay. If not, we'll have a very hilarious video to laugh about, and you guys can tell me how stupid I am when they catch fire. Right now what I'm going to do is I'm going to take my propane torch. Let me show you guys this. This propane, barbecue propane tank, and my Harbor Freight blowtorch. I'll put the link in the description where you guys can find this Harbor Freight. It'll give you the number on it. This thing is awesome. But I'm going to take this. I'm going to heat up the chimney stack up here. And the reason why I'm going to do that is I'm going to try to create a draw on this before I even light the wood. Okay. What I mean by draw is it's just common physics for heat to rise. So when you get a chimney stack hot, what it's going to do is it's naturally going to start sucking the air up and letting the heat rise out, okay? Because it's colder outside. It's naturally doing that. So, and the hotter it gets, the more it's going to draw. So I'm going to heat that up so that I can eliminate some of the smoke that we're going to have. Heat that up, then I'm going to come down here and heat up the tower a little bit, and then I'm going to get the wood and put the wood on fire. I've already got some wood here in the feeder. So I'm just going to put the torch in here and get it going after I heat that up. So let me find my lighter and we'll get this going. Turn your gas on. Okay, so it's going. I know you saw a lot of smoke. Part of that is I'm forcing air in. And if you look inside of here, you can, I don't know how well you can tell, but the fire is being sucked. It's not being pulled up the feeder. It's being sucked down this tube and into the burn chamber. You see a little bit of smoke, and the smoke is because our feeder system is very primitive right now and it needs to be refined, but it's working really well right now. I can tell just by looking inside of there. So, and our smoke is really limited. This is heating up already really hot. So it seems to be working. And if you listen, I don't know how well that's picking up. Hopefully you're hearing that. It's a rocket sound. That's why they call it a rocket mass heater or a rocket stove. The sound you're hearing is the air drawing through this tunnel past the wood and up the tube. You're hearing kind of a little small roar, kind of rumble. So it's working, and I'm just going to let it burn. I'm going to keep feeding it, and I'm going to start checking my temperatures. Now, fire brick takes a long time for it to heat up, but let's check this out right now. Putting this on Fahrenheit. The outside of this brick right now is 57. But like I said, it just started, so it's going to take a long time for the outside of this brick to heat up. This burn chamber, or the feeder, come on, focus on that. 92. See, this part is going to get hot because it's metal, but hopefully it doesn't get too hot. Let's check here. We're at 182 and climbing fast. Check here. 51. And like I said, the brick's is going to take a while. Let's check here. We're at 277 and climbing fast. This thing's working great. Okay, I'm gonna have to get something to stand on to check the very top. The temperature here, we're at 250, 260, 206, or excuse me, 160, 60 degrees right there on the stack. So the goal is with this rocket stove, when it's all said and done, the idea will be to consume all of the heat before it heads out the exhaust. Okay, we should want the exhaust to be touchable. Okay, it shouldn't be so hot that we can't touch it. Now with this setup right here, this is just temporary, just so I don't get smoked out here in the shop. So, you know, those temperatures, it's not going to matter too much. But what I'm watching is just to check the draw, because one of the other issues we had while we were burning this inside of here with no chimney was the heat's going up to the ceiling and it's heating up my ceiling area because heat rises, and then the draw starts going away, okay? Because it needs cold air at the top of the chimney to continue to have a good draw. So that's the other part of why we wanted to set this up in the chimney to see how it would work. So that's it for now. I'm going to edit in the last part of this once this heats up real good, so I can show you what kind of temperatures we're looking at, and you can see that. But I'm going to stop for now, so talk to you guys in a second. Okay, so we're back. This thing's been running, I don't know, maybe 15 minutes now. I don't know, I wasn't watching the clock, sorry about that. But let's show you some temperatures. Let's start with up here. I'll switch to Fahrenheit. We're at 188. To 31. $185. About 255. Get this to focus. Yeah, there you go, 255. Let's just do a side with a brick here. 192. $282. We'll judge it down here. That's actually considerably hotter than it was. This is 336. Let's try this top one. 179. The side. The top of the side is 360. And the lower part of the side is 214. Get that to focus. It's not. You have to just trust me here. Let's see if we can get this lid to shut a little bit better. There we go. I just put a piece of wood in there, was a little too long. So, cap temperature is 260. The side, roughly at the top, 303, 304. The bottom of the steel feeder tower, 456. What was this? Yeah, okay. Now the brick here, 564. 65. Get this to focus. Closer to the tower. 397. Now, let me take a look in here. I don't know if you heard that just now, but this thing was really going quite well. I'm going to have to adjust the... I've been using this long rod here to kind of poke at this. Now, what I had said in my first video is that we're having problems with using the sticks. We're having problems with the air-fuel ratio fluctuating severely because the sticks are not falling down. They're burning, they're just not falling down the feeder at a rate that's consistent. So what happens is the fuel will burn away, and then there will only be a part of that stick that won't break, and it'll just sit there and it'll only have like a part of it, one or two, you know, pieces holding everything up, and it won't start feeding again until those embers, those coals break and fall. So that's a big part of why we're going to switch to pellets, is to avoid that problem. But with this chimney stack the way it is, I don't have to worry about it smoking, but it does fluctuate the temperature. Now this temp gun goes up to 1,000 degrees. I'm going to start it. Let's get it on Fahrenheit. I'm going to start it here. We're at 225 and we're at the edge here. I'm going to go in. About right here we're at, did I say 225? I meant to say 125 here at the edge. It's about 130. Go halfway in that brick and we're at 260. Go to the next brick and we're already at high. So inside this chamber, I'm not even touching, I'm not pointing it at the embers, I'm just touching the bricks at this point. Before I even get to the embers, I'm at over 1,000 degrees inside. So this thing is running really, really hot, and which is a good thing. That's what we want it to do. I'm going to take you outside. Okay, so I'm going to take you outside. Sorry about that. I hit the wrong button on my camera and turned it off. I don't think you're going to be able to see anything. There's zero smoke in the air that I can see. Yeah, and you can't see well enough to even judge. I can't see any smoke out here. I can't smell anything. When I run my barrel stove, it'll smoke out the neighborhood sometimes because it takes a long time for the stove to heat up to the point where it's burning cleanly. When it's burning cleanly and I got some embers and coals going on in there, then it'll clear up and I won't have hardly any smoke whatsoever. But there still is some smoke, it's just not much. This thing's not producing any smoke at all. So that's great. Now, you're probably wondering how well this heats. And right now this is not set up to heat up my shop, okay? When you set up a rocket mass heater or a rocket stove, and let me explain to you what the difference is. A rocket stove is something people cook on. What they'll do is they'll create a contraption real similar to what I have here, and they're just basically putting a pot where this is, or frying pan or something like that, and they're cooking with it. Because with a few sticks, it'll heat up this, you know, the heat rising out of here will be enough to cook off of no problem at all. Okay, that's what a rocket stove is. You can design something like that for camping or whatever, and it makes cooking real efficient. Heating up coffee when you're out in the woods or whatever, it makes, like I said, real efficient. You can do it with just twigs, and you don't have to worry too much about it. With a rocket mass heater, you have a big cover, whether if it's a compressor tank or a barrel 55-gallon barrel or whatever you want to use. It sits over the top of it. You got about a 2-inch gap between the barrel and the top of the stove, and it's usually flat. The heat is just penetrating that, you know, it's just hitting it and hitting it and hitting it straight up. And it's going to be really, really hot across that top surface. Then the air is forced to come around the side of this and then exit the bottom. So you have this outer shell that is just collecting heat, collecting heat, collecting heat, and radiating it off the top. And that's where you get your source from. Right now, we're not getting a lot of heat off the side of this. I mean, if we put our hands next to it, especially right here, we definitely can feel some heat. But we're not getting a lot of heat because the heat is going up and out of here, okay? We don't have anything to collect it other than the fire bricks. A rocket mass heater that would typically be used like in a cob style house or something. If you don't know what a cob house is, it's basically sand and clay and straw and stuff like that they used to make a house out of. Think Lord of the Rings Hobbit house type material. So what they'll do is they'll run their exhaust along the floor, you know, and zigzag it and then out the building, and they'll put cob all over the outside of it and fire bricks and stuff like that, stuff that will collect the heat. They call it a battery, if you will, because it's collecting and storing the heat. Then once it's hot and warm, you could literally just not run any fuel in your stove, let it burn out, and all that mass is just radiating heat because it's collecting it. Real similar to like radiant heating in floors. Okay, see, we're running out of fuel in here. Let me put some more in. But yeah, real similar to radiant heated floors. You know, they're using hot water or something, some sort of liquid. Let you look inside there. We're getting the flame wicking up the top because, again, that's not designed real good. We have a few sticks. Here's some shorter ones. I'm not going to run this for too much longer. I basically just wanted to test and see if it would work with the chimney. And it does, works well. So, okay, got that in there. Let's look inside now. Okay, you see that and how the sticks are right there? It's going to take a minute for those sticks to catch fire because the one that was lit is on the opposite side of them. The air is flowing past those non-lit sticks instead of throwing fire on top of them. If that ember was closer to me and I put the sticks on the other side, this thing would flare up really fast. And the reason it would is because wood doesn't burn, it gasifies. It creates a gas, and then the gas itself is flammable. So as it heats up, it's going to create that gas. Now the plus side is, this wood on this side is going to heat up from that temperature inside of here because it's over 1,000 degrees inside there. So it is going to heat up, and I can see some gas seeping off the wood, and that stuff is going to catch fire. So it's just not running as efficiently as it could until those things light up. So anyway, that's it for now. I just wanted to share all this with you guys so that you can see this whole project coming together. And for those who would be curious about the draw with bends, I got a 90 here, 90 here, 90 here, essentially a 90 here, and then essentially another 90 here at the bottom of the stack. And it's drawing really, really well. So it's performing really well as far as not smoking inside my shop. So far so good. I'm thinking home run at this point, but you know, we'll keep experimenting, trying different things, finding out what's the most efficient, the best way to do things. I'll be changing this whole, basically from the riser back to a number of different configurations to try to figure out what works best and why, and we'll share that with you guys in the video. So anyways, thanks for watching. Like always, subscribe, comment, like. Go like our Facebook page. The link will be in the description. If you're on Twitter, follow us on Twitter. The link will also be in the description. Check out our website. That link's in the description as well. And yeah, send us a message if you guys are curious. If you have any questions, leave a comment below. You know, give us some activity. Tell us if you like this series or not. All right, talk to you guys later.